He's in Italy.
In Italy, yeah.
How's the weather there now?
Hope it's warmer than what we have in New York. This is ridiculous.
Uh,
Here is pretty good.
mm.
He's in Italy.
It's not bad here today, right?
No,
okay.
it is cold, Luke. It is freezing. It's windy.
Yeah, a little bit chilly. A little bit chilly. But it's a sunny. It's beautiful outside.
Yeah, it's sunny. I would like some more heat though. It's cold. I should be wearing sandals. Let me get the document. Does everyone, well, no, what? I'm just going to share the document anyway. Luke, we can start whenever you're ready.
Okay. Okay.
I'm going to put in the chat the documents.
Also, I didn't see Mike's solution in the Dropbox. So I wonder if you have it.
I should have it. I'll search for it now and if I'll let you know.
Okay.
But I think it was in there. I just have to I'll double check the file now.
Okay. Oh, in fact, if you go to chat in the Slack, I mean, I just sent it through Slack, I think yesterday. So if you cannot find it, you could just go back to Slack and find.
Oh, okay. Okay. Got it. All right. Let me do that.
All right. And I will share my screen. All right. So Vivian told me that Mike has done this before to share his solution to people. So and also we only have an hour, and I do want to keep save some time for QA. So I don't want to go through everything line by line. What I want to do is I want to highlight what he did. I think really, really good. And maybe just a couple of details that I might do differently. Let me just quickly remind you what this problem is about. So it's a data science challenge. So essentially, Pepsi want to predict the sales, okay, in the unit of dollars, for their product. Okay, so this whole data set is anonymous. I mean, the product ID is anonymous, so we don't really know which product they're talking about. But they have different products, right? Different kind of drink, I suppose. And then and then they have the date, right? So they're tracking the sales. They're tracking daily sales. And then for each day, whether they have a promotion or not, whether they have promotion or not. And then price, right? So the product might be of different price at different day. So that's all the data that they have. I mean, all the features that they provide us. And what I say was, this is essentially a time series, but the dollar sale, the sales of the products are kind of removed after 2019. So essentially, they want you to predict, even though this is kind of disguised as an imputation problem, but really what they expect us to do is to predict the dollar sales throughout 2019. Okay. So here's a few things. So the data set should be unique according to product ID and date. So even before we look at the data set, this tells us the granularity of the data. What is a unique observation? What is a role in this data set? And this very often what we need to first recognize when we got a data set. So it's a product at a particular day. Okay? And for each product at each day, we want to know whether there's promotion, what's the price they're sold at a day, and then the dollar, the volume, the sales. And here, I think this is probably something they added after they saw some other applicants' response, because probably a lot of people try to figure out the relationship between the promotion and price, just reasonable, right? So when there's promotion, price should be lower. It is pretty natural to suspect that. And what they say is don't do that. There's nothing there. Okay, so just don't do it, right? When you see this kind of message. Dollar sales is null for all of 2019. Essentially, that's what they want us to predict. So now we have, in fact, this is a supervised learning problem explicitly, and the target variable, dependent variable, is dollar sales. So here they stated the task. Okay, they stated the task. So they want you to clean the data. They, they mention explicitly imputation, imputing missing value. So that's something you need to have some discussion there. And then they also, so this is a supervised learning problem. What we want to do is to predict the cells. So what can we use, right? What kind of feature can we use to predict that? So here they brought up particularly this maximum retail price, and also give us an example here that the blue line that we see here is the prices of a product. And this is one product, and then and this is the fluctuation of the prices. So we see a few things. First of all, we will have some missing value in the prices. Not just after 2019, that's fine, because that's what we're supposed to predict. But if you look at here, the blue line is kind of broken here. That means we do have some missing value. We have to somehow impute it. We need to come up with a good way to impute it. And then the maximum retail price that they mentioned was that for particular, if you look at the blue curve, it seems that, well, we have like, just look at this orange, horizontal line. It seems that that's the highest retail price for the normal cases, right? For the normal cases. Now, this one, we do have some pike that doesn't really, doesn't look normal, right? So essentially, the maximum retail price is kind of the maximum retail price that happens during a certain period without those abnormality considered. Okay, so we need to somehow create this orange line, straight line, horizontal lines. And according to their description, that's one of the most important features. So they already, we're doing supervised learning, and we're going to do feature engineering, and they already explicitly say this is the feature that you need to create. So this part, you should take it for a coding challenge, that we got to create this and then use it in our machine learning algorithm. So that's that. And design an algorithm. So, okay, you want to design an algorithm, right? So right, so it should be a supervised learning, and they ask you to think about what would be the dependent, independent variable. So coming up with independent variable, that's feature engineering. And dependent variable, you could just stick to the dollar sales, but I think Mike came up with a good idea, which I'll briefly mention later. So that's also a common thing that people do, that instead of the most natural dependent variable, we might want to come up with a different one to see if we could get better result from them. Okay. Yeah, and then so we saw that the maximum retail price is something that we have to come up with, and then during some day you probably have lower price than the maximum retail price. Those are considered as discount, right? So Where was it? Yeah. So you would like to predict the sales. You would like to predict the sales, and then you would like to know whether having some discount is a good strategy to boost the sales. Right. So that's something that they mentioned. So you probably want to look into that too. This is very important. Okay. Whenever you are asked to do forecasting, you don't want to use the future information to predict the past. This is like a big no-no. So if you ever do that, you're likely to be rejected immediately. Okay, and this just indicate what they want you to submit. Indicate what do you want it. So you need to have a Jupyter notebook that explain your process, and you also this part is more like the Kaggle type. So product date and your prediction of sales, and I think they want the dollar sales. So if for whatever region you predict, say, you know, some transformation of dollar, say log. If you do the log transformation of the dollar and train your model to predict that, you have to do the exponential to bring it back. That's essentially what they say here. So that's a brief, you know, just remind you what the problem is. And this is essentially Mike's answer, Mike's solution. And I think he did first of all, he did a really good job. When I first look at this notebook, a few ideas are great, so I like it a lot. So I turned to Vivian and asked her if Mike did get this offer, and yeah, he did, which is not surprising at all. Yeah. So just to he did some EDA, and from EDA he found something really interesting, even though that he might not be able, he didn't use it for, because that's probably not something to be used directly in the supervised learning setting like this. But he did find something really interesting. I'd like to, you know, quickly bring up. And for the engineering, I want to spend some time at this part to create a maximum retail price. Okay. As you again, just remind you what that is, right? So we want to construct this orange horizontal line, which is not like trivial. Which is not trivial. We need to somehow use the code to recognize this kind of, you know, spike and then remove them. So that's that. He also came up with this price shock. So sudden change in price, does that impact the sales or not? Okay, that's another feature that he came up with. Just a few words here that this is essentially a time series problem. So if I did this problem, I will probably use the sales from the last season, right? So let's say I want to predict the February 2019. I will probably use the sales from, you know, February 2018 or something like that as a feature. That is not using future to predict the past, right? So I could use that. Mike didn't do that. Okay, even though he already got a kind of reasonable, good R-square, but I think that is pretty common that people want to use the previous information to predict the future. So that's something that you could give it a try. You can give it a try later. Missing this, so he talked about the imputation strategy, but I think it's pretty straightforward. This part I'll probably just briefly talk about it and leave it to you guys. And then the last part is modeling. Also, he went through a pretty standard modeling process. So again, you should be able to read the code. I'll leave reading to you guys, but I'll briefly talk about give you some remark about this modeling process. Okay. So let me start with the data exploration, just EDA. First of all, drop the duplicates. So in the guide, they say explicitly that each product ID and pair, each product ID date pair should be unique. Okay. So when you see this, you would like to check if that's the case, right? You like to check if that's the case. And if you actually do that, right, how do we check that? Well, we could simply just group the data by product ID and date, and then compute a count, and then sort according to the count, right, from the biggest to the smallest. And if you actually do that, you will find some of the product ID date pair have more than one record. Okay. I think a few of them have two. That's why you will have to drop the duplicates. You'll have to drop the duplicates. Okay, so that's what he did here. I think he definitely, when I saw this, I'm pretty sure that he has checked the data. He had checked the frequency of the product ID and date pair, but he chose not to show here. I think this is a smart thing. Okay, so you need to inspect the data carefully, but that will, that requires a lot of work, and you don't necessarily want to show all of them in the notebook. You just highlight the most important part. So drop the duplicates, and then make sure that there's no other duplicate. Okay, make sure there's no other duplicate. So here, just a little suggestion that if you want to make sure there's no other duplicate, I will probably just do group by product ID and then date. This should be size, right? Okay, so that gives you the size, right? That gives you the size of each product ID date pair, and then you could simply get the maximum. If that equals to 1, that means every pair has only one record. Nobody had, because maximum is the biggest frequency. Nobody got more than one. So it's probably easier than this. And then you would like to make the date. So change the date to daytime is a common thing, and you could generate the month, year, weekday feature. So other than date, you also have whether it is, what was it? Yeah, this is whether it's Monday, Tuesday, or up to Friday, Saturday, Sunday. So that's the weekday. Okay. Okay, that's that. And here I think is another good idea that Mike came up with. So we mentioned before that the question asks us to think about the dependent variable and independent variables. Very often, if we're given a supervised learning, thinking about what independent variables that we could use is pretty natural. Everybody would do that, right? But Mike also came up with this idea to think about, hey, what kind of dependent variable can I use? I know that the final goal is to predict the dollar sales, but do I want to just predict it? Or if there is any sort of like an intermediate stage, I could, reach first and then, get to the final result from there. So he came up with this one, the volume, just in terms of, can Pepsi, is how many cans do I sell instead of the total dollar amount that I sell, right? So that's another possible dependent variable. So that's what he did. So he created this column and then update this data set together. So the volume's here. The volume's here. And this one, so just quickly check this out. This one doesn't have a missing value in volume because we have a missing value in dollar sales, but that's really because this is 2019. That's, this is actually a test observation even though we put them into the same data frame, but that's actually, you know, the one we're going to predict. Now, we're going to see this assign function a few times. So I think it's a good idea for me to just briefly talk about this function a little bit. It's actually a pretty useful function. It is like the mutate function. It's like mutate function we have in R. Okay, and just for information, this is a function that they created later. They created, I think, in a newer version. In the old version, what we usually do is, if we would like to create a new column, we'll simply do, you know, data column name equals to some old column and apply some function. That's what we used to do, right? But now they give us another way to do assign. So essentially, so this is, let me say, from, what can I do? Let's say from, okay, let's say just I want to change a volume to string, a very simple one, right? So we know that to change a volume to string, what we could do is to apply to string, right? Then this column becomes a string, right? Make it a string, and the thing is that this is not a mutating operator, so we create this new series, but the old data frame does not change. And that's just a new series. You want to put it back to the data frame, right? We have to, you know, do extra stuff. So the assign function works this way. If this new series that you create, you want to put it back to your original data frame, let's call it volume string, something like this. You could use this assign function and use this volume string, the new column name, as if this is a parameter argument of your assign function, and then specify what will be the value. What will be the value? Okay, so that will give you this volume string here, volume string here. But the standard way to use this function is not really like this. Okay, this is essentially what Mike did above, but the standard way to use this function is more like the following. Okay, you will pass a function like this. Okay, let me comment this out, and oops, I did something wrong. df is on the, wait, what is df, because this should be df on the school. Okay, so the typical way is like doing this. Okay, instead of pass the data, you know, the data frame itself, you will pass a function, and this function is supposed to be applied to the data frame that call this function. Okay, this is lambda keyword, right? This is lambda keyword, and so that define a function. This function is designed to apply to something. Okay, what is the input to this function? The input to this function is whichever data frame, call this assign. Okay, so in this case, this is actually data. This is actually data. So what we want is really just data volume applied, you know, make everything do it, which is essentially this. Okay, but why is what is the benefit of going with this way? Well, if you want to chain another assign, function, okay, for example, if you only want to keep the first three digits, right, might not make sense, but just let me give you an example. So my 3-digit equals to now lambda and the df. Okay, so now I could use, let me quickly tell you what I'm doing. So now which data frame called this assign? Well, this whole thing, this is the data frame that call the second assign. That being said, this, you know, the data frame that we're going to use we'll have this volume str column that we create with the first assign function. If you just pass data here, you won't, right, the data frame, it doesn't have the volume string column, right? Volume string column is created by this function. So if you want to change, just like when we did mutate, if you want to have mutate after mutate after mutate to create a column on top of the last column that we create, on top of the last column that we create, then you could go with this way, use the lambda. So I would just do something lambda, oops, as maybe just as get the 3-digit. Okay, so that would be 3-digit like that. Okay, this function is pretty nice, especially for people who are familiar with mutate type of transformation. So I would like to, and I'm going to use it to create an MRP. So I would like to quickly mention that. I would like to pause a little bit. Are there any questions about this assign function? Okay. So once you create these features, you would like to do visualization to explore them. So this should be like very easy for you now. You just need to go through a lot of them. I want to highlight this one. Okay, so first of all, this is the scatter plot of the sales, dollar sales against price, right? So you will suspect that the price impact the sales, right? And if you look at the graph, some of them, like this one, some of, by the way, I should have mentioned this. I think one thing that Mike did particularly well in this notebook is that there are actually, I forgot how many different products are there in the data set, but he always randomly choose some to show the visualization or show the result, show the feature that he created. Okay. Using visualization is a better way to tell people what you found. Okay, and because it doesn't really make sense to squeeze all the visualization into small space, so he usually just do 3 by 3 and randomly choose 9 product. I think that's a pretty good idea, and do subplot to plot them. So these are 9 random products. But from here, we do see for example, for this one, we do see some kind of, quadratic pattern. And here we do see some quadratic pattern. So from here, where was it? Okay, I think he wrote it in the sort of the conclusion for the EDA part. But the finding is that if you do have this kind of quadratic pattern, okay, that usually indicate you might be able to come up with some strategy where you could find the best price, So the price that gives you the highest dollar sales. So it's a possibility. That's a smart finding I mentioned before, which is not immediately useful for this project, but the finding is interesting, which is from here. And then he also found that now this is the dependent variable that he kind of created the volume, and it seems that the volume and the price has a linear pattern. So when the price goes up, the volume goes down. Okay, so that's something interesting. All right. So that's that. And then again, the volume or the dollar sales against other features. These are typical explorative analysis. I'll leave the reading to you guys. Feature engineering, and the first one he did was to try to find a maximum retail price. Okay, that's this graph here, and essentially I think this is actually a coding test. So Okay, so he did a little more EDA, right? So what he tried to do is try to find the relation, kind of visualize the relationship between the price and the volume. So the blue, curve, right, that we see here, line chart that we see here is a price, and the orange one is a volume. The orange one is volume. What he wanted to show here is that when price suddenly go up, the volume goes down a little bit, but I don't think, I mean, from my perspective, I don't see a really significant different, but this visualization you could interpret a little different way. Sort of the right hand side of this price change, kind of the sort of right hand side seems a little bit lower, but whether it's significant or not, I'm not quite sure. Okay. The point is I want to highlight this. So this part is just to get the product, to just get a particular product. So you could choose whichever product ID you want to show, and then this just select the product, select the rows of those products. And one thing we need to pay attention to is that in this data set is not really sorted according to the date. For whatever reason, the date column is messed up. So for this product, we need to sort the data. So we sort the data. Sorry. So we sort the data by date. Like this. Okay. And then you see that the index is messed up. That's why we need to do the reset index, and then plot. Well, I think there's another possible way. You can simply just set an index to be date. Okay, and then just choose the product ID. Not product ID. I'm sorry, not product ID. We want to plot what? We want to plot price. Let's say we want to plot price. And then you could simply just plot it. Yeah, the good thing about this is that the x-axis will be date. And then the plot function will decide, what is the most visually pleasant way to show the date. Like in this case, you don't want to show 2025, January 1st, January 2nd, January 3rd. You only show you the years, not even the month, okay? That would be still too crowded. It shows you the year. But if you use just the indices, then it's gonna be gone. That piece of information is not there. Okay. So, if you reset index, at least you got the right curve. So either reset index or just use the date. Either way is fine. And then this is the function or the chunk of code he used to create the maximum retail price. I want to spend some time to talk about this function. All right, again, that this part is just, so when we create, when we create a maximum retail price, we create a maximum retail price for each product, okay? So that's why what we want to do is we want to do it for a specific product, and then again, we need to sort the date, right? Because obviously the strategy is that these dates are going to have the same maximum price. Why? Because they are in the first region, the range. So we would like to order the data according to the date. Okay, so that a similar date will be together. So that's that. And again, he reset the index. That's fine. And so probably let me try to break things down line by line. Actually, yeah, let me do that a little later. So what I want to show you first is that if you run this chunk of code, you will see that it takes some time to run. Takes some time to run. Quite long. Okay, now it's done, and then it give us the result like this. Okay, I redid the code a little bit. It will be, a lot faster, faster. So I want to introduce the original idea down there, and then show you this how this could be, accelerate. So this is just, using Mike's function to handle one product. I want to show you how nice this idea is. Okay, so first we choose the product and then store the data according to the date. That's necessary. Okay. And then we create this MRP. So before we do that, okay, let me comment out these and then comment out these, right? So before we have the before we do anything, this is the price curve. This is the price line chart, whatever. Okay, and then we would like to come up with the most reasonable orange line that we should come up with is like here, right? Like here, we do see kind of like a horizontal upper bound for most of the data in this range. So that's something we'd like to come up with. Okay, so this is line that we do. So the MRP is, we would like, again here, here the data that we pass here, or what we assign to this MRP start with a data frame. But I would say go with that lambda that I introduced before, makes more sense. So this is like the window function. This is how we do window function in pandas. Okay, so essentially you have a price column. Okay. So you have a price column, which may be maybe like 10. It's not working. Okay, $10, $9, $9.5, and $15, and then again $10.2, so on and so forth, right? And then the rolling function allow us to roll a window. Okay, so if you do rolling function and specify window equals to 4, that means these are going to be considered together and generate a value here. We're going to generate some value here. Okay. How we would like to generate the value, that depends on the aggregating function that you pass. So you do have a pandas series, okay, and then you could call the rolling function, and after that you might want to use a aggregating function. Let's say we use mean. I'm sorry, let's say we use maximum, because mean is difficult to compute. Let's say we use maximum. Okay, maximum. So the value we generate here will be 15, because that's the maximum for the 4 numbers. And then we move our window to the next position. Okay, so it's 9, 9.5, 15, 10.2. So for the second value, it's again 15. So the rolling function allows us to move a window to scan through a series. And then for each position, we generate a value according to whichever aggregating function you use here. I see a question in the chat. Let me quickly take a look at it. Oh, okay. Thank you, Courtney. Any questions about this rolling? Okay, so that's a rolling function, and you could use apply. Okay, you could use apply to apply a aggregating function. So the aggregating function that might apply here is mode, right? Obviously, if you look at the window, let's say our window covered this range, it covered this range. Obviously, these particularly high values, they're not going to be the mode. They're going to be outliers, right? So we want to get rid of outliers. What we could do is to aggregate a mode from a window. So window is 90, right? And if you go back to this example, instead of maximal, if we use mode, right? So what is unfortunately, I should do something. Okay, let me just do 29. By the way, this is why Mike used 90 as window. Okay, if you just use a smaller window, it's still probably that the outlier is no longer that far away from the common range. Okay. So here, if we use the mode, we got 9. Yeah, we got 9. And then for the next window 9, 9, 15, 10.2, the mode is again 9. Okay, so that's why he used mode. And just, it is possible that a particular window cover 8, 8, 9, 9. So the mode will become 8 and 9. You might have more than one mode in some of the windows. So that's why he had to choose one. I think he just choose one randomly, whichever first mode that this function returned to us. He went with that. By the way, this mode function is from SciPy. Okay, I'll leave reading to you guys. If you scroll all the way to the top, you will see that mode function is loaded from SciPy. Okay. So any question about this? So once we run this function, we could also visualize the MRP. So that would be this, right? That would be this. Okay, and now you can see that you have some missing value at the beginning. Because it requires 90-day window to create a first value. So the first 89 days will have no value at all. So what can we do? We could backfill. So this MRP is the orange line that we create, right? So we could first backfill, which means we see the volume. So we have a missing value here. We could use the first non-missing value in the future and backfill. So we'll fill this up. So this gap here will be filled by this number, by the the left hand point of the orange line on the right hand side. This as well, this will be filled with this number. Okay. The only part that cannot be filled with the backfill function is here. So we could use the the forward fill. Anyway, forward fill. That's that. So after we run this, then you will see those broken part will be gone. Okay, those broken part will be gone. All right. And then the next step is to remove those abnormality. Okay, so what we could do here is to just choose, for every day, we choose the smaller one between the MRP and price, right? For example, like at this particular day, the day with this particular, pike here, the smaller, so obviously the orange line is lower. So we're going to choose that. we're going to choose the orange point instead of that height. Okay, so just to I'll leave the reading to you guys. Okay, so it's either, you know, if if the price, okay, for every point where the price is bigger, we want to replace you know, replace them by the MRP. That's essentially what he did here. So after we run this line, those, you know, abnormality will be gone, and then eventually we redo the MRP by taking the maximum. So in this particular case, you no longer have that problem. But in some other cases, you might have the maximum retail price go down and then go up. But you want to get, so the thing is, in some other cases, you might have like the price goes something like this, but at some day it just, you know, doesn't go up for some time and then go up, right? So the maximum retail price might be something like this. Okay, but if you don't want things to go down like that, you wanted to just you know, maybe let me use another color. You wanted to go all the way to here and here. Okay, if that's what, sorry, if that's what we want, we could use a so-called, so that's essentially what Mike is doing here. Okay, just make sure that the maximum retail price never go down, because the maximum retail price, it's not supposed to go down and go back. So you know, he wants to get the maximum up to a certain point. For every day, he wants to use the maximum price up to that day. Okay, nothing goes down. Okay. That's essentially what he did. It's a very nice idea, cleverly handled this problem. I just want to show you how we could modify this code, follow the same logic, but modify this code to make it faster. It says what? Oh, I see. Because I took the start time. So just to show you that with Mike's code, it would take about 3 seconds, to finish this task. So if you change, so as I mentioned before, using assign, a more reasonable way is to use a lambda function. So that's the first thing. I still get the price and use a rolling function. The logic is the same. Probably I would change into 90 so that the logic is exactly the same. Here, when we use apply, when we use an aggregating function, instead of use the aggregating function from SciPy, you could simply use the aggregating function from you know, each of them is a series, right? So when you use a window to scan your series, each time the window will cover a subseries, which is still a series. So for that series, it comes with the mode function, which is good. But the mode function might give you more than one mode, right? As we mentioned before, it could be 8 and 9 in some of the subseries. So we could just simply use another aggregating function max, okay, to cover it. And then the filled NA is the same. So just the backfill and forward fill. And then this is another thing. So instead of writing, you know, because what we really want to do is just to replace the price. If it's higher than the MRP, then we want to replace it by MRP, right? So that's what happened in this line. A easy way to do this is to find the element-wise minimum. So just for every day you compare the MRP and price, and if the MRP is smaller, just go with MRP. And then eventually, you know, so the last part is to get the maximum up to date, which is, you know, Mike write a a custom function here. But, you know, to get the maximum price up to date is the so-called cumulative maximum. So let me just quickly introduce this idea. So you could have, again, you could have like a 10, 9, 9, 15, 10.5, and then 10.2, so on and so forth. Okay, so the cumulative maximum is really, at this point, the maximum is 10 itself, which is the biggest number up to this point. And for the second place, the cumulative maximum is 10. 10, because among these two, the biggest one is 10. And then again, this is 10. And then this is 15. Because for the first four, that's 15, and then 15. So really just the maximum up to the date, there is a function for that. There, where we're at, okay. There's a built-in function, cumulative maximum, for it. And the idea of this kind of cumulative maximum, cumulative sum is actually quite useful. It could, you might see some of them in your interview. So I will encourage people to get familiar with it. And then if we do it, oops, yeah. So if we do it this way, it could be 3-4 times faster than using our own function. And being able to choose a good built-in function, it's very often a good way to improve the efficiency. That's already a 4 times faster. But here I would like to introduce another idea that if you think about what we did, so what we did first with the MRP is to smooth the curve, right? We want to smooth out the curve. And the first step is to try to figure out what are the abnormality. So and the orange one that we the orange line that we created was like a smoothing price. And if you think about smoothing a curve, usually what you would do first is the moving average. And really moving average is moving a window and then compute the average, right? That's a typical smoothing function. The problem is if we go with, let me see what I have here. Invalid syntax. Really, I need another one. Okay, so now the problem with the moving average, is it doesn't really capture the higher point. It doesn't really capture the higher point. It find an average. So because we have a lot of very low points, the average will not be close to the, the horizontal boundary that we try to approach. That gives us a problem. So whenever you have this kind of problem, well, you want a medium, right? So instead of letting the lower value to drag it, you probably want to go with median. The median gives us a little bit better result, but still not very good, right? And by the way, I use 30-day window. If we use 90, it become better in these regions, but still in many regions it's still not good. Okay, so to fix that, we could keep in mind that the median is like the 50% percentile. We could use instead 90% percentile. So this is a quantile function that allows you to get the percentile. And that will give you a lot better result. Okay. And with that, we could just go through. So the rest of them are the same as what I showed you before. I changed my code somewhere. All right. So that pretty much gives me the same thing. But this is another I don't know, 6, 7 times faster. Together, it will be 20 to 30 times faster than if we just use mode and use our custom function. Okay, so just to show you that, first of all, coming up with the idea is not easy. That's the most important part. But once you have those ideas, very often, you could find the built-in function in pandas and NumPy that allow you to carry those ideas out. Try to use them. Usually, that will make your code a lot more efficient. Okay. Any questions about this part? Okay, I thought I'll finish this faster, but it's almost 11 now. I think the missing part is pretty straightforward. There's only one thing, another thing that I would like to bring up. Okay, so obviously, so the thing is, here, Mike came up with the idea of the volume. So obviously, in his supervised learning problem, he will have to train a model to predict the volume in dollar cells, which is great. And he also tried different features, which is definitely what the the coding challenge is about. Coding challenge is about to figure out what the feature are important that impact the cells, right? So he did all the in the necessary steps, and then eventually come up with a conclusion. I think everything is good, except one thing I would like to highlight. I think it was in somewhere in his conclusion. Let me look for it. Feature selection result. Here we go. He said that the volume is clearly easier to predict than dollar cells. I will agree with him that the volume is probably a better dependent variable than dollar cells in this case. Essentially because of the linear pattern that we saw above. Because we want to figure out the factor that impact the cells, right? And the price itself is entangled with the dollar cells, and the relationship between the price and volume is linear for almost all the product, pretty linear for all the product that we inspect here, which is a very nice relationship to be captured. Okay, and I'm pretty sure that through the modeling process, you will also see other evidence that the volume is a better dependent variable to use here. But just saying that it is easier to predict, it is unclear what based on what he said so, right? And one thing is probably when he did the validation process, he probably found that the prediction for volume always result in better score than the dollar cells, right? So volume, dollar cells, the score is higher for volume than the dollar cells. I'm not sure if this is what he indicated, but just keep in mind that the score for different dependent variable might not be comparable directly. Right? So your R squared for the volume and the R squared for the dollar cells, you cannot just compare them directly. So you want to avoid this kind of misunderstanding in the view. So that's the last part I want to highlight here. Okay, so try to elaborate a little more about this kind of statement. Why you think volume is better, And the direct comparison between the R square is probably not a good way to justify that. All right, so that's everything I have for this coding challenge. If you have questions, I could stay here for a few more minutes. Otherwise, that's it. That's everything I have. Thank you.
Thank you, Luke.
Mhm. So a good way to compare the two results is always by, because they're not this. So one possible way is you have the volume, you have the price. You could construct the dollar cells, and then from that dollar cells, you could figure out the R square and then compare with the R square from the direct prediction for dollar cells. That's one way. But usually, if you want to predict, if the goal is to predict the dollar cells, predict dollar cells directly is usually better in terms of the R square. Okay, so that's probably not what you want to do. So what you want to do here is to see what significant factors that you could extract from the two models. It seems that the volume could give you more clear idea what the the significant factors are because of the relationship we have there. Anything else?
Just a quick point, or a quick question about the backfilling. So in the beginning, you said it's really important to not use future data to feature engineer the past.
Which part did you?
When you're backfilling for the for the right.
Yeah.
So say you have some
Right. That.
Like,
so
is this not a violation of using future data?
Very good point. Very good point. In fact, not only here, but also when I use 90 days windows and I use the center. So that being said, yeah, this is a very good point. I didn't have time to go over that detail. So so when I use center, what does that mean? That means when I have, let me just use 1, 2, 3, 4, 5, 6. Okay, when I use window equals to 5, the new feature I'm going to create is here. So that is already using future to get this. And then moving your window to the next point, I got another one. I'm gonna use Y for that. Again, use future to create feature here. Very good point. Very good point. But if you think, and the violation happens up to here. Happens up to here, including using the center equals true and also backfill. Okay, it happens up to here. What does that help us to do? It helps us to let me use this chunk. Okay, what it helps us to do is to figure out this orange line, and that essentially tells us, well, in these regions, the most common high price is here, not here, right? So it sort of gives us help us to figure out the range that is near to abnormality. And with that, we're able to remove these abnormal prices. And then the feature that we actually create is really here. So the cumulative, after we remove those abnormality, the actual feature that we create is the maximum up to the current date. And the maximum is from the historical data. Okay. So what I try to say is that the feature we actually create only uses the data before the target date that we try to create a feature on. Okay. The only violation we had was when we try to figure out those bad prices. Okay. And it is, in a sense, not a violation because, those are abnormality. And we use the feature information, not directly create the feature, but we use them to figure out the abnormality. So that's not a violation, sort of border. Yeah. But the problem is, without thinking about the future data, you won't be able to, like here, right? How do we know that this is not an abnormal data, but a real price jump? Because, well, the price they have afterward. So without using a little information from the future, we won't be able to, we won't be able to differentiate this and this. So we have to use a little bit. Does it make sense?
Yeah, that makes sense.
Okay, but, right, because we use the future data, then what should we do? So now we need to have this maximum retail price feature. We use them when we train the model. That means when we want to use this model to make a prediction, we also need to have that maximum retail price feature for the test data set. But for the test data set, we might really, we might end up with a test data set like this. So imagine a test data set that stopped here, right here. Okay, we first encounter a price jump, and we don't know what will happen in the future. So at this point, do we want to keep this as our maximum retail price, or do we want to remove it and say that the maximum retail price is below? So when we make a prediction with a real feature test data set, we won't really know what will happen the next day. So we won't be able to use the method that we proposed here to decide whether the max retail price should be higher or lower. Okay, but at that point, it is probably the business decision for whether we actually raise the price or the prices stay. The price, the abnormality we see are really just abnormal data. So in the future, we have to for prediction, we have to use something other than what we're doing here to decide whether the maximum retail price is higher or not. But at least that's still doable. It wouldn't just invalidate our model, or if your model cannot be used for prediction, your model is not useful at all, right? But you can imagine that wouldn't happen to our model, because the retail price is something that we should be able, or at least the company should be able to decide, to figure out. So they will be able to figure out that.
So basically, you need sort of different rules.
Yeah.
For the edge.
But that's a very good catch. Yeah. It really is too short amount of time. Otherwise, this function that we have here is really worth a lot of discussion. And the idea is beautiful. I like it a lot.
Thanks, Luke.
Anything else? Or I will end the session. All right. Thank you. Talk to you guys later.
Thank you, Luke.
Thank you.